Okay, moving on, we got 12.4. So 12.4 is all about infinite geometric series. Infinite geometric series. So here's your formula here. If, there's two things here. If my absolute value of my ratio is less than 1, then I use this formula. If it's more than 1, then it does not exist. D, N, E. And we'll comment into that later. For this formula, all I need is my first term and my ratio. That's the only two things I need to solve this. So let's go through some examples. So first one there says a sum goes from 1 to infinity, 5.8. So this is my first term. This is my ratio, if you remember from the formula. So my ratio is 0.8. Is that less than 1 or bigger than 1? Well, that's less than. So I get to use this formula. So my sum would be my first term, 5, over 1 minus my ratio, which is 0.8. And when I plug that in to my calculator, my sum should be 25. And it makes sense because it's getting smaller each time, because it's less than 1. So it's getting smaller. So your numbers eventually are going to get really, really close to 0 and add up to be that. Let's do a different one. So here, if I look, my first term is 1, my ratio. What am I multiplying by on top? At least, I know I'm alternating, so it's going to be negative. What am I multiplying by on top? 1, 3, 9, 27. Looks like I'm multiplying by 3. What am I multiplying on the bottom? Looks like 4. So my ratio is negative 3 over 4. Well, negative 3 over 4, we want to change that to positive 3 over 4 to figure out which one of these I use. So 3/4 is less than 1. I can do it. Here we go. First term divided by 1 minus ratio. And when I plug that into my calculator, it should give me 4/7. 4 over 7, or whatever it gives you as a, oh man, blanking out, decimal. Next one, my first term, my ratio, 5 over 3. If I plug into my calculator 5 divided by 3, I get 1.67. Is that bigger than 1 or less than 1? That is definitely bigger than 1, which means my sum does not exist. And if you think about this, every time it's getting bigger and bigger. Well, if it just keeps growing, it just keeps growing to infinity. So there is no sum. Okay, one more of these. My first term is 2. My ratio, what am I multiplying by each time? Looks like I'm multiplying by negative 2. So then I gotta, to figure out which formula to use, I gotta change it to positive version, so positive 2. That's also bigger than 1. So this is a does not exist. Two quick word problems. It says a pendulum is released to swing freely, travels 18 inches on the first swing. In each successive swing, the pendulum travels 80% of the distance of the previous swing. What is the total distance the pendulum swings? Total distance, I'm talking about sum. So for sum, I need two terms. I need my first term and my ratio. My first term told me my first swing travels 18 inches. After that, it only travels 80%. So if I change that percent into a decimal, I get 0.8. So then I go to my sum formula, 18 over 1 minus 0.8. And if you do that, you get 90 inches. One more today. Fred the Flea is on the pendulum having a grand old time. The first swing of the pendulum is 40, and it swings only 75% of the distance for each successive swing. What is the total distance that Fred travels? Total distance, sum. So for sum, I need my two terms. I need my first term. Said my first term I travel 40. Each successive term I'm only traveling 75, so 0.75. And then when you do that in your calculator, you should get 160 centimeters.